Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome back to WebRTC Live. I'm your host, Arin Sime, founder and CEO of WebRTC.Ventures. WebRTC.Ventures is a custom design and development agency focused on building live video applications. We're here to help you take your application live. You can learn more about us at WebRTC.Ventures. In today's episode of WebRTC Live, I'm pleased to welcome a guest who's an expert in real-time WebRTC applications. Sergio Garcia Murillo will talk with us about enabling the next generation of live video architectures with Real-Time AV1 Scalable Video Coding. In addition to having almost 20 years of telco experience under his belt, Sergio's been a senior solution architect and lead developer on several open source projects. He's proven expertise in SIP, IMS, VoIP, video communications, including WebRTC and streaming technologies. He's currently the founder and main developer for Meedoze technology and media server lead at CoSMo Software, and Millicast principal engineer and solution architect. Thank you so much for joining us today, Sergio.
Hi, hello, Arin. Thank you for having me here.
Pleasure to have you here. And so for those joining us, thanks for joining us today on WebRTC Live. We have a good number of people registered for this. This is a really interesting topic and a wonderful person to speak with us about it. Our format today is going to be a little more conversational. So Sergio will probably show us a couple of demos, but mainly we're going to talk a little bit. So this is a great episode for you to ask your questions about anything related to AV1 or any of the other work that Sergio's done and is well known for in our industry. So feel free to just put your questions in the public chat or in the Q&A section of the tool. Either way, we'll make sure that those get presented to Sergio. So Sergio, I thought to start today, and we'll talk technology, but also a little bit of world football here. So I was watching Twitter yesterday, and I have a confession to make to you that I hope you don't mind. I'm a Chelsea fan. And yesterday, you were watching Real Madrid and Chelsea play, live streaming online, and spoiler alert, there was a tie, so hopefully you and I can still be friends today. I assume you were supporting Real Madrid.
Yeah.
If it makes you feel better, in the Spanish league, Real Madrid is my team, but when they're playing Chelsea, I had to root for Chelsea. It was an exciting game, but also some really interesting technology implications there. I'd love to hear a little more about what you were saying on Twitter yesterday and how you watched the game.
Yeah. I think that, well, let's wait until next week, until the back game to see who's laughing. So I think the good thing is that today we can laugh to both. Yes, well, in fact, it was fun yesterday because, I mean, I live in a building when I cannot choose the provider of the internet provider that I have. I can only go cable with Vodafone. I mean, all the other providers only have DSL, which is not, I mean, I'm doing the streaming, so having 10 megabits DSL is good for testing, but not for working. And with Vodafone does not offer the Champions League or in fact any football at all in their offering, and I cannot buy it for Orange or Vodafone, so I cannot watch it online and not in the TV. So the only thing I have is my brother has Orange, so I'm using his account. The only thing is that Orange has been smart lately, and they are disabled to view a match from two different computers or two different devices. But luckily, that's the thing when you have a good provider. I mean, they have the DAS player on one side, and they do the check of multiple viewers in JavaScript. So just putting a debugger in the correct place and putting the error to null, I was able to see the whole match. But I mean, is what happened when you don't integrate very tightly with your media server, something like that.
But yeah, so we definitely have an issue of general web security here, and there's an advantage to all of us who are JavaScript developers sometimes. But there's some underlying concepts too here around the business of football, as well as the technology of live streaming, which you do a lot of work in. So this I think there's some interesting implications here of the challenges you faced yesterday. And I face a lot too as a football fan, world football fan in the United States. We don't always get to see all the games we want to see. And we have similar, regional blackouts with sports broadcasts and things like that in different markets here in the U.S. for even teams in the U.S. So, yeah, what are your thoughts on streaming in the Champions League or dare I say the Super League?
In fact, Lorenzo Minero had tried to troll me when saying about the EuroLeague, but I think that he was quite spot on, because I think that one of the topics about the EuroLeague, of course, is about the money, but it was about the right of streaming games online, because I mean the money and the revenues that you can get streaming events now online are quite the order of magnitude higher that you can get with traditional TV rights and how you broadcast this. So I think was also a movement by all the football teams to try to get into this business, the streaming business, and to be able to stream and to offer all their matches to their fans. Because I mean, if you imagine how many fans Manchester United or Chelsea or Real Madrid has, I mean, and being able to try to just, without having any kind of intermediaries, to provide the technology and the experience to them, to personalize it to them. I mean, it is huge. I mean, and now we don't have any kind of limit with the technology. We can stream a game to many millions of people watching it online. So if you can just think about how the experience, the different experience that you can provide to these fans, and how you can charge them. I mean, because it's at the end, it's all about the money. I think that it is a very hot topic right now, and I think it's going to be the future, at least in some kind of streaming and real-time communication. Because obviously, I mean, watching a game with 30 or 5 seconds of delay, you cannot bet with it. So I mean,
exactly.
Which is another part of the business. So I mean, luckily we offer a real-time CDN that it is in fact one of our main or our target use cases, to be able to provide these kind of services to global events. With interactivity. I think is one of the things that these events are lacking right now.
And this will be my last bit of football commentary, but I feel obligated as a U.S. citizen to make clear that I am not a supporter of the Super League, because I know that the American owners of some of the English teams are justifiably getting a lot of criticism over this. And I think there's a lot of beautiful things about the beautiful game that the Super League was going to contradict. But I do think there's some interesting possibilities here that you're starting to say that hopefully will be a good side benefit, sort of a good long-term benefit for us as fans, that even though the Super League was a pretty bad idea, maybe it will spur some other change in other ways, because it is a global sport, and the importance of these domestic leagues in the nations is really important. But sharing that, the allowing more global viewership is important to the clubs and to the fans. And you started to talk about latency there, and this is a good segue to AV1 and to the work that you've done too. You mentioned, gambling, betting around a game, that needs to be done in a true ultra low latency live scenario, certainly. Other use cases, just like watch parties and stuff, I think. I mean, talk to us a little bit more at the use case level of the importance of truly real-time streaming and how AV1 is going to get us there.
Yeah, well, I think that there are a lot of use cases. I mean, we in Millicast, we now are working into a more advanced feature set, like, for example, the stream party that we have been talking about, and also being integrated with the video conference to be able to provide some APIs so people can implement products in that mix both interactive between the presenters and the viewers, So, and it's kind of surprising that the kind of services and the diversity of services that people are implementing with Millicast. So, I mean, we have a wide range of, I mean, from cattle auction to to people that are doing post-production of films. So it's really crazy what people can do with the correct APIs. And I think that AV1 is at the same time is going to be an evolutionary step of video codecs, because it will just reduce. I mean, we are always trying to get more quality, more image size and less bitrate rate. So it is just evolutionary step. But we have also very nice feature that could change how we do things in the future. Especially, I'm talking about the better integration with SVC, how RTP is done with SVC, with AV1 and SVC, and the compatibility with end-to-end encryption. So I think these are the topics I would like to talk about in this talk, and also try to provide some demos so people can see that it is not. We are not talking about 1 year from now. We are talking about right now. I mean, because I am encoding it with Chrome, so it's something that even obviously it is not going to be the single-use codec used for everything. And I think that it is a real option right now that people can start to think if it makes sense instead of balance between CPU consumption, battery, and quality, and things like that. And also, it obviously it's not as fine-tuned as BP9 or BP8 in Chrome, but I think that it is an option that we can already start using in production, and some people will start using right away.
Perfect. Well, yeah, please tell us more about this super WebRTC and AV1, and yeah, let's get a little more technical.
Yeah, the first thing that I would like to is that AV1 has made a quite clever choices, or I would say that it has get the requirements from the beginning to be able to work with end-to-end encryption and to be able to have a better SVC mode. So we have been working with Millicast and CoSMo in AV1 for almost 2 years now. I mean, the first test that we did was like 1 frames per second in QCIF. So it's a long time ago since we started to work on it. And we have been working in our media with defining the RTP specification. And the good thing is that we have defined a dependency descriptor that allows the AV1 SVC to be information to be coded in a way that it is codec agnostic. Because one thing that we have seen that from the experience of working with BP9 and BP8 is that sometimes how to handle all this SVC in the SVU was quite complex. So especially the people from Google try to get in a way that we could express how these frame dependencies of the codecs or the video stream can be expressed in a way that could be, I would not say easy to understand, because it is not easy, but powerful to work on with. So what AV1 has made is try to also to create an agnostic way or a generic way to specify these dependencies that can be used also with other codecs. So they also, so what they had done is first to be able to work with end-to-end encryption, they have put the information in a header extension, so it is not in the RTP payload. So when you use end-to-end encryption, that we can talk about it later, you don't need to check the payload of the codec, and you just need to check the RTP header extension to do the processing as the SVU. So this allows AV1. AV1 supports end-to-end encryption without having to do anything, because it is like it was one of the requests at the beginning that it has to work with end-to-end encryption. So what the dependency descriptor does is that I don't know if you have seen how the ugly boxes of SVC when you have a lot of boxes with the I can show it. And
yes,
yeah, typically, I mean, typically you have in all the SVCs document, you see this kind of crazy box here that just represents all of the fragments in all the spatial layers and temporal layers. So meaning that you can have two kind of scalability, that it is spatial, meaning that you send the frames in different image resolution. So typically you send in half. So you send one VGA, one SD, and another, or it could be QVGA. In this case, it is only two, for example. So they will be these layers, these frames from here will be the ones from VGA, and the other ones will be for HD. And also you have like different frames per second resolution. So each of these frames represent one of this representation of the frame in this scalability structure. So what it means that here you have a frame encoded at VGA, here you have a frame encoded in SD, and depending on which layer you will have more a more image size or more frame per seconds. So this is common to all video codecs. So you can see almost the same diagram for S265, for BP9, for AV1. So what the dependency descriptor does is not try to define it let me go back to not to define it in a way that it is specific to AV1, but it just said, well, specifically thinking from an SVU perspective, is like when you receive they have divided the frames in kind of chains, meaning that if you receive these frames, it is okay. I mean, for example, you have you can have different chains for each of the spatial and temporal layers. So what it allows you to do is, okay, so if you are going to receive this frame, and this frame, if you miss any of the other frames, it is fine. You don't need to worry about it. So what this allows is to help with the resilience of the strings, because if you know that you will be able to know when you receive a packet, if this packet is from a frame that it is needed to continue decoding the stream or not. So you can apply different FEC mechanisms to each of the packets. You can apply different recovery mechanisms for a packet. So for example, if you receive a frame, you are missing a frame, but you know that it is not in the chain, it means that you can drop it.
right.
That you don't have to ask for NAC for this packet in order to continue decoding the stream. The quality will be a bit lower, but it will not be a drop. You will not have to request it, wait for the NAC, and you will not have to add more delay to that. So in this regard, the AV1 the dependency descriptor does two things. One is to allow to implement this, to do layer selection in the SVU, and also help the SVU to decide which recovery mechanism they have to apply to each of the packets and of the frames. So that the good thing is that it helps. First, it allows a faster switching when you go from one frame to one spatial layer or one temporal layer to another, because you know exactly which frames do you need and if you have it or not. And the other thing is that you can also apply different recovery or mechanisms depending on which frames or which packets has been lost. which reduces the number of the end-to-end delay, so you can have it very, very low, and also reduces the bit rate that you have to spend doing retransmission and NACing. So this is I think that this is one very important property of the AV1 dependency descriptor. And just to get more into from theory to the real world, as I said, it is not only implemented in. It is not only for AV1, but for example, if you enable the feature the flag for enable in Chrome, you will have it for BP9 and BP8 too. And I'm not sure, I have not tested, but for H.264. So what it means is that just being able to do the switching base of the dependency descriptor will allow you to have the same code for AV1, for BP9, for BP8, and for H.264. That it is something that, as SVU developments, I mean, each time that a new code comes in is quite of time because you have to implement everything again. And in this, and I think that it has been a very good addition from the AV1 team.
Nice. And so, do you think to the end users of an application, when that application is using AV1 now, what is the biggest impact that they will see? Is it higher quality, or is it maintaining the same quality in lower bandwidth scenarios? What is or both?
I think that AV1 has two main use cases or two differentiators. I mean, in theory, because it depends then on the encoder and the implementation itself, but it promises to have lower bit rates than BP9. And I see some comparison that has is not in real time, is for streaming, but it has I don't know, I think it was 20 or 13% less than BP9, and which obviously will be very interesting for content in high quality, like 4K, 60 frames per second or things like that. But I have shown also that it has a very significant quality gain when you are doing low resolution with very low bit rate. So, for example, I know that people from Duo are using, or their target is to have AV1 in QVGA at 30 kbps. So it is like being able to watch a video in a stream bad network condition. I think that it is also going to be a very powerful feature for AV1. And in that case, also most implementation are ARM optimized, so it is very focused for mobile phones with very low CPU consumption in this low bitrate mode. And I know that people are have started to think of it about having the normal BP9 stream and then just adding a small layer, just to be able to have the two resolution, one with BP9 and another with AV1 with a very low resolution and very low bit rate for this extreme bit rate networks with bad network conditions.
So it can be beneficial in a number of scenarios, but the most noticeable area perhaps would be in those lower bit rate and lower resolution scenarios. So really beneficial for mobile users and as we or on our devices.
Yeah, probably for normal resolution is in mobile. It is not the best codec right now because of the CPU and battery consumption. Yeah, and also there are no hardware encoders yet on mobile phones. So, but I think that for example, for us that we have streaming is more like broadcasting. For the top quality is going to be important, but for people that are doing conferences or something like that, maybe for this lower layer it could be very, very interesting too.
Yeah, interesting.
So I think that what I would like to show is a small, as I said, we have been working with Litho Media with our media, sorry, to help in the RTP with the RTP spec for AV1. And we also write a test suite for testing the implementation. That it is what I'm going to show next. What we have done is screen. So what we did is just to create a small extension to the peer connection client, just to enable the scalability mode with AV1, and we have created a mockup server that just sends the loopback in the video in loopback, allows you to do layer selection. So what you see here is that we are going to use the three special layer with 3 temporal layers, and here is the dependency descriptor filter that you have to use in order to enable it.
If you're able to increase your font size a little bit in that window, I think that'll help
okay.
our viewers too.
Oh, no, I can, sorry.
No worries.
Okay, so what I'm going to... So here is the peer connection client, slightly modified, and what I'm going to do is to connect to this ID here, 6, is the same one that we are going to connect. So here that you see is that this one is sending the capture. I have a virtual camera with OBS. Mm-hmm. So it is sending like half the 1080p. And then in the right hand side, we see the bitrate of each of the layers, of the 9 layer, and we are able to switch from one to the other. So for example, if we go to the lowest layer, it will start sending a much lower resolution, and also only at 3 or 4 FPS frames per second. You see that the outgoing bitrate has dropped. It is sending less than 200 kilobits per second now. And if we want to, for example, go to a higher layer but keeping the same frame rate, it's just going to the next layer and then a special layer. This one is now we have gone to the full resolution, but keeping the frame per second low. So now we can go back to the normal stream. And this is kind of what the code that it is behind is my SVU in Meedoze. So this is the same code that I'm using for doing the layer switching in an SVU with my media server. So you can see that you can go from one to another. So this is the first thing that we have been doing. And also what we have done is to, we are trying to get the SVC extension for WebRTC. So to be able to have this, to be able to control these modes in Chrome, we have created a patch. So this is just the master Chrome, but with compiled locally with the patch that it is available. It is being reviewed right now. And the good thing that can you see the screen, or I can increase the
That's good.
more.
That's great.
Okay. So you can see that here we have plugged in the get capabilities API. So here you see, for example, this one were already available in VP9 and VP8. You have the scalability modes to enable 2 temporal layers or 3 temporal layers for VP8 and VP9. And we have that is a patch that just plug the code for AV1 that has a lot more scalability modes available. So I would like to talk a bit more about the different modes.
Okay.
So the L means L is one spatial layer and two temporal layers. So this will be one spatial, two temporal, one spatial, three temporal. And there is this cake and sheet. What it allows is to just typically you have like the keyframe for the lower resolution is also in the same frame that the highest one. So when you have an iframe, the amount of bitrate is a bit more, is higher than what you have in a non-iframe picture. And if you what this key sheet mode does is just to not send all the iframes on all the layers at the same time. So it just displays or shifts it one frame or two frames. So what it allows is to have a smoother bandwidth when you have when you are sending iframes. With at the end is better for bitrate estimation, and also better for transmitting and have a more reliable stream. And this last one is what it is called S modes or KSVC, in that works similar to what simulcast is doing today. All these previous modes, what it does is that the higher resolution spatial layer depends on the lower ones. So there is a bit of bit rate that it is wasted in these SVC modes compared to non-SVC mode. In the S mode, what it does is to send, like in simulcast, you send two different strings within the same RTP session. So you are still using able to send different resolution at a different bit rate, but if you are only planning to send one of them to your participant, then the bit rate overhead is lower.
Mm-hmm.
And finally, I have put here, this is, well, I'm going to open a new one just to show you. This is our Millicast. This is the staging environment, because we have not yet updated this version to production, but we will do hopefully this week. And here you can see, let me see, there are too many videos here. Anyway, just stop the one. This takes a while. Probably because I have the, I mean, yeah, let me close the capture of the, it's demo time, so. Okay, so I will switch probably because I have too many things going on the same computer. It does not allow me. Okay, so I don't know what's happening, but either OBS is killing me, or
OBS can definitely be a processor hog, and then when we're trying to present and talk live on this at the same time, totally understandable. Let me ask a couple of questions that we have from our audience here too. So Darren would like to know, with this technology on Millicast, is it going to be possible to distribute video content to other platforms such as YouTube and Facebook Live? And is there any SRT capability coming into Millicast?
Not to Millicast. I mean, we think that WebRTC is better than SRT. I think that we are working as the first question was in there about the WIP. I think that WIP is the way forward for supporting end-to-end capabilities with WebRTC, especially for the broadcasting industry when we want to have support probably end-to-end encryption from the capture to the distribution. So we will seamlessly work with an end-to-end encryption. And I don't know if you know WIP, but WIP is an effort that we are doing in IETF to specify a ingest protocol for WebRTC. So, for example, like right now, most of us, or most people, are just doing our RTMP for backward compatibility. If you want to have some hardware encoders or things like that plug into your server, for example, YouTube or whatever other streaming platform, or you do some kind of like ad hoc protocol for WebRTC that you can implement easily in our browsers. But what we want to have with WIP is like a standard protocol to be able to replace RTMP with WebRTC when using WebRTC. So the idea is to be able to have this implemented in hardware encoders, so you can have your capture card in your studio or whatever, or that you just can put a URL of a WIP server, and you can start streaming to Millicast, to YouTube, to Twitch, to any platform that support it. I think that it has been very, very well accepted, and the technology, the technical proposition is quite easy, and we hope to have some encoders that start to implement it quite soon. And it's something that we will benefit all for it, because it will not only for Millicast, it will be for any WebRTC plans for that wants to implement it.
Excellent. Yeah, and you started to answer some of this already, but Alex asked about WIP and WISH, and wanted to know, in addition to the current status of it, are any hardware encoders already planning to support it, like Teradek or AGA? And Alex definitely was in agreement with you that we need to get the broadcast industry away from RTMP.
Yeah, this is something that we have been working with some of these hardware vendors to have it working. That the only thing is that we have to progress a bit more on the draft before. I mean, we have not even enabled it into Millicast into production, because, I mean, it has to be an agreement of all the players in the industry. So we don't want to start working on something that may have some slightly changes and make us do the work twice. But it's something that we want to have it as soon as possible. And I think that there are some hardware encoders and companies that are really interested, and I hope to have it soon.
Excellent.
And also regarding the broadcasting industry, I think that it is something that we are also working on, that it is something that we miss now in WebRTC, that it is support, for example, for SDR with 10 bits, inputs with 444. So this is, I think that currently we are not close to what the quality in the broadcasting industry is expecting. So I think that it is also something that we can have with AV1, and BP9 has also started to support it with Profile 2, but it is something that we want to start having it as soon as possible with AV1.
Excellent. All right, we're starting to get towards the end of our time here. So for our viewers, if you have any other questions, this is the time to go ahead and enter those into the chat for Sergio. Sergio, what's coming next for you? What sort of things are you excited to work on now that AV1 is making its way into production? And what comes next for AV1 or WIP?
There are too many things going on. I mean, the difficult part is deciding on which one you want to be involved, not to have all your time. I think that we still have to do quite a lot of things in AV1. There has, I mean, we have, for example, there is an issue in Chrome. When you enable AV1 SVC, the ramp-up bit rate is very slow. That's what I wanted to have the stream up before doing the demo, that we have not been able to do, because it takes a couple of minutes until you get to an HD quality. So this kind of small details has still to be ironing out in Chrome. And obviously, for example, AV1, when we announced it, SVC, I was only able to get like 15 frames per second in VGA with SVC. Now I'm getting more than 30 with. Well, I have a very good desktop here, but I mean, the speed that we are, especially the people in Google and in our media are going is very huge. Also, I am very interested in WIP for obvious reason. I'm the main proponent, and also we want to implement it in Millicast. Having support for HDR with 10 bits and things like that for quality, for broadcast quality, multi-opus for multi-channel support, audio support that we already have in. There is some interesting APIs for capturing the visual port of the own tab that would be very interesting for enable some use cases. I mean, I think that there are a lot of interesting things yet to be done in WebRTC. People think that we are done, but I mean, I think that we are just starting to have something stable when done. We need to now to improve.
Nice. Yeah, I'm sure that there is definitely a lot of interesting things coming, and choosing which one is always a challenge. Where can we focus our attention, because there is so much going on right now. We have another question from Alex Williams here. In AV1 SVC versus simulcast, is it correct that with simulcast, the publisher might be sending 3 times streams at, say, 500 kbps, 1 meg, 2 meg, or a total of 3.5 meg upload bandwidth used, whereas with AV1, you would send multiple streams or layers at 2 meg total upload speed?
In fact, you can do both. I mean, with SVC, like what I explained before, the S modes and not S modes, no, the KSVC modes, is that with normal SVC, what you will do that you will be sending, instead of 3 different streams in at 5 kbps, 1 megabyte, and 2 megabytes, probably you are going to send something that it is less in bitrate in total. But when you just choose the correct layer to forward, it is a bit higher than, for example, the simulcast. But if you go to the KSVC mode, you will have the same behavior that you have with simulcast, like sending 2 different encoded or independent encoded stream without the same RTP session. That makes the switching and the SVU much easier, because all the packets will come you in order. It's not as in simulcast, when you can have the packets arrive at different, not in order, and you can have layer drops, which makes things not so. The switching is a bit less inefficient, so you will have both modes in AV1 SVC.
Excellent. All right, thank you. All right, Sergio, any other closing comments that you want to make, or anything you'd like to point our viewers to for more information about AV1 or what?
Well, just in case anyone is more interested in AV1 SVC, the technical details, I wrote a blog post about explaining all the inner things that I don't think that much people has read until the end, because it is too heavy. But if anyone is interested, it's definitely there. And also you want to test it, just wait a couple of weeks, months for it to come available in Chrome, normal Chrome. And obviously, you want to test it in Millicast, you are able to register your free account, and you will be able to test it for free.
Excellent. Excellent. And we'll be posting video of this session of WebRTC Live to YouTube soon, as well as to our blog. And we'll include some links to some blog posts about AV1 and SVC and WIP as well for our readers, for those who want to do the frame-by-frame analysis. Like you said, Sergio, it's a little heavy, but important stuff, definitely. So, Sergio, thanks again for joining us. Really enjoyed our conversation. Best of luck to Madrid next week in the Champions League. I can't root for you, but I will wish you best of luck. And we'll look forward to all of you joining us again for the next episode of WebRTC Live. To find more about our upcoming episodes, follow us on Twitter at WebRTC.Ventures or join our email list at WebRTC.Ventures. Sergio, thanks again for joining us today. I really appreciate it.
Thanks you too for hosting me.
Thank you. And thanks everyone for joining us today. Let's make it live.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.Ventures to learn more about our custom design and development services and to learn more about upcoming episodes of WebRTC Live.